So if you want to learn the deterioration model parameters, or if you want to do a post-training analysis on the data, we need to have our data in a .mat file format. So originally the database would be either a .csv file or another file extension, but it's extracted to .csv. And from the .csv file, we have to convert it to a .mat file so we can perform the MATLAB operations that we would like to do with it. So in order to do so, what we have to do is to go to the main menu of OpenIPDM. We go to the Tools menu, and we select Read Real Data. So once we select Read Real Data, toolbox will open. This toolbox have multiple tabs on the top for loading the data, attributes, interventions, and network scale. We're going to go through them one by one. So load data, as really does what the name suggests, is to load the .csv files. So we have the element inspection database. We click on load to load this file. For example, so elements inspections. So once we load a file, we would have a list of columns. So these are the columns inside this file. And we have to select some columns, and some of these columns are mandatory. So all of these columns that I'm going to select right now are mandatory, and it's really preferable to keep the same order of columns for the moment. But for now, like we have the structure ID, the inspection date, the span number, the element. The element here, it means like what type of element. So is it beam, is it slab, and so on. The element number is the element number within the span of the within a given span in the bridge. And then we have material and element type. The material and element type are interchangeable in some cases, but for now we're going to select material. And we have to select also XA, XB, XC, XD, which contain the numerical evaluations of the structural deterioration condition. And then we have to select the inspection ID, which we can match to the inspector ID. So from this, we can tell which inspector has performed the inspection. And element ID, which gives us a unique element ID for the structural element. Now, I have to mention that, as you notice, that we've loaded the element number and the span number. Now, these, in case we will only use them in case if the element ID is not available. So the element number and the span number can be employed in order to generate a unique ID for the element. But in case if we have the element ID, we will not use them. So this is for the inspections data file. So I'll click OK to load the file. And also I have to mention that when I'm selecting multiple columns, I'm holding on the control button or the control key in the keyboard. So I will click, I will load the next file, which is the structures data. So I would click on load and go to the folder demo data and structures database. I would double click on this file, and again I would load some of the structural attributes. So the structure number I would load it for sure, and I would click and hold the control key and select also latitude, longitude, total length, slab length. Now these, some of them are like optional, or like for example the latitude, longitude, and so on. Surface area. But for example, the construction year is mandatory, and the status is optional as well. AADT, which is the annual average daily traffic, tracks, and lanes. So these are the main columns that we're gonna load for now from the structures database. We click OK, and then we move on to the next file, which is the inspectors data. So this one, I would load the file that contained the inspectors responsible for the inspections. So I would select this file, and in this file I would load two columns, the inspection ID and the inspector ID. So these are the two only columns required. Click OK, And for the main.csv files, I'm done. So, but there might be other files that I would need to load. So we will see that later on. So after this section for the load data section, I would move on to the section with data filtering. So because the database is too large, like there are millions of records, so it would be useful to kind of categorize or filter the database based on the element category. So for example, we want to filter the database based on all the beams in the data. So to do so, we select this filter by, we select element, and we have a list of categories which show up in the next menu. So we can pick any one of these. So I would select category 4, for example. And category here, again, in the real context, would translate to either a slab or beam or like something that for an element that would exist within the bridge, or a type of element that would exist in the bridge. So this is for the filtering. Now for the next input is for including the interventions or not. So there are 3 options. All means that extract all the inspection data regardless if the element underwent interventions or not. The second choice is that extract all the inspection data only for the elements that never underwent an intervention. And for the last option is extract the inspection data only for the structural elements that underwent an intervention. So if you want to train a deterioration model or learn the parameters of deterioration, we want to select the without interventions. So if we click on this, the toolbox will ask us to load the interventions file. So we go to the file and we go to realized interventions. And in this one, we have to load the mandatory columns. So we have the structure number, the starting date of the intervention, the activity code, which tells us what type of intervention that took place, the element, and the element ID. So these are the mandatory columns for the interventions. And for the reason why we didn't take for example, the finish date, we only took the start date, is that whenever there's an intervention on a structural element, it's unlikely that it will go over multiple years. So most likely it will be done within the same year. So that this for all the columns, we click OK. And we have a message that this is loaded successfully. And then we move on to the next input. So this input is optional for the status. And this is really because in some databases you might have structures that are that has been demolished, but there are inspection data for these structures. So you might not want to rely on such an old inspection data. So you might filter by status, and so it could be active, demolished, and others. But for now, for this demo case, you see we only have the active option. And again, this is an optional input. So we are done with the main input for the load data. We move on to the next tab, which is the attributes. So the software has the files loaded, has the columns that we've imported, but like it doesn't know what each column means. For the most part. So we need to assign what's the meaning of each column. So that's what we're going to do in the attributes. So we have, for example, the construction date. We click on the sliding menu and we select the construction year. We have the inspection date. We select the inspection date here, the structural element number, and the number of spans, the structural material, and then a list of 9 structural attributes in addition to what we already have. So the loading the structural attributes is really optional and depends on if we want to rely on structural attributes. So I'm selecting right now number of structural attributes. You could fill all the files, but in case if there's like if you'd like to fill only a few of these structural attributes, it would also work. So based on this input, we are ready to extract analysis ready data or export filtered data. So for the export analysis ready data, what really means is that we would have multiple .mat files that we can load and use in like either in the training model training toolbox or the post training analysis and so on. While for the export filtered data is that it's going to export a .mat file that would have a table, and that table is filtered based on the selection that we've made here. So that's what means export filtered data. So in like most cases, we're going to rely on export analysis ready data. So if you click on it, you see because the database is really too small, we would receive like right away the window to save the file. So we can say demo ex, and we can save the files here. So we can save the files as you see. So the files right now are saved in the current directory, and we see we have different files. Each one of them contains specific type of informations. Mainly what we're gonna be working with in many toolboxes would be the sorted data file. That's the one that we're gonna rely on in most cases. So this is for the export analysis ready data, and this is really if you want to train the model or to do some post training analysis. Now moving on to the next two tabs, which are like kind of tabs that would facilitate and accelerate the work in some contexts. So for example, the interventions tab, which really is more about managing the interventions files or like databases that we have. So for example, imagine you have multiple databases for interventions, and these databases, they do not overlap. So there's like an additional piece of information in each database. So that's why what you can do is select like, okay, I have 3 databases or 4 databases, and these databases would be .csv formatted. And then if we click on merge, what it will do is that it will ask you to load each one of these files, and then it will start merging them based on the and generate like one file that has unique information based on the 3 files. So this is really something to facilitate, but it's not a mandatory step in any process. The other like tool or like process that we can use to facilitate organizing the files. So here we have the intervention data, and here we can load the intervention file as we did before, and just extract a data file, .csv file. So it says CSV from MS Access. So it would give a .csv file based on the filtering criteria that we've done here. So it's really, again, for organizing the database, and this really relies on the interventions file. Here we have, for the last part, interventions cost, and again, this is really to extract the costs as .mat files. So all of these are really optional, and they are not mandatory in any process or toolbox. We move on to the last tab, which is the network scale. So in the network scale, we have the, so here we have, if you want to export, so before what we saw is that we filtered based on a specific structural category, and we extracted that structural category for all the bridges or all the structures in the network. So for example, we said that we're gonna have, we want to have all the beams from all the bridges. Now in the network scale, for this one, the files that we extract from here are really useful if you want to do some network scale analysis for multiple types of structural categories. So we're gonna see like the first file that we need to load here, in addition to the files that loaded earlier. So in the load data, in addition to these files, we have to load the elements details. So we load this file. We go to demo data and elements details. And here we have to load the structure number and span number, element ID. So we have element number and quantity. So, or it should be element number and quantity and element. So these are the columns to be loaded in this file. We click OK. They're loading these files. And we see here that in the data management part, I would see that it will ask us to select the quantity column. So we've loaded that in the elements details. We load the quantity here. And we select the traffic AADT, and the tracks percentage columns, and the total length. So this is really, we are extracting some data for the like network scale analysis. And we can pick, so here we have to pick multiple structure categories, because again, as I mentioned, the only difference between this tab and the previous, or the tab that we started this tutorial with, is that we are working on one structure category. Here we're going to work on multiple structure categories. So we're going to load some of these structural categories, and we're going to select OK. OK. So we have picked these, and we can go on like to extract the data. But the thing to be mentioned here is that the elements without VI is that for example, if the criteria for visual inspections is to evaluate the status or the deterioration level in the material, then some of the structural elements will not be involved in that part. So for example, the foundations are in general, they are not involved in whenever we have a metric to that's associated with the material. So it's more, the foundations would be evaluated based on the performance. And there are like different criteria. So we can select elements that we don't want there. So that's for what it means. And then we can click extract data. And this would give us like multiple .mat files that are organized based on for the network scale analysis. So I'm going to click here, and we have the file loaded, done. And this because basically we have the database is really small. So we create demo.net and we click save. So right now let's have a look at demo.net. So if we double click on network data, and we can see that we have the structure ID, we have here the one of the columns, so it would be the DGMA, and we have here the structural categories in each bridge. So because we selected 4 structural categories, specific ones, and these structural categories would be mentioned in the elements file. So if we load the elements file, we see that the categories are 20, 21, 22, and 23. And these correspond to column 3, column 4, column 5, column 6. So you see that this bridge has 2 elements of 20, and these are the inspections data for that element, and so on. So this is really like the way the network scale data is organized. Now, for the sake of comparison, if we look at the file that we get from the previous from the load data tab, so when we clicked on the export analysis ready data, we get the sorted data category 4 if we load it, and it's the name is SSPD sorted. So if we double click on it, we see that we have each row represents a structure, and each column represents an element, and that element is really uh, the element of category 4. So this is basically what it means, and these are the inspection informations. So in the other .mat files, there are sufficient information to describe what each column means, and in case if there is some ambiguity in the like what each column means, you can either refer to the PDF document, or you can also have a look at the code. Inside the code, there's like comments that mention the order of the elements and so on.